Okay, building on our understanding of combinations is the goal. And consider a group of 6 people. How many ways can a group of first 2 people be selected and then 4 people? So this is obviously an NCR question. We're choosing. And so NCR, writing out our formula, NCR n factorial over r factorial times n minus r factorial, and we've got basically in this one we've got 6c2. Okay, and we've got 6 factorial over 2 times 4 factorial, and entering that in, you can get 15 for your answer there. How about if we look at 4 people selected? So that would be 6c4, and subbing in everything as usual. And this time we've got 6 minus 4, which makes 2 factorial in the brackets there. And if we crunch that, we also, you can try it yourself, pause and try it yourself, you get 15 as well. Coincidence? Maybe have a pause of the video and have a think, is that coincidence? Is it not? Well, it's not a coincidence. Choosing 2 out of 6 is the same as not choosing 4 out of 6. That sort of reminds me of the idea of negation or complement. So choosing 2 out of 6 is the same as not choosing the other 4 out of 6, and so we definitely get the same answer, and we should. So that brings us to the next result, and you can see there NCR is the same as NC n minus r. That's an important result, so make note of it, and maybe write down your version of why possibly that could go in your summary. Students, I encourage you to take on board these quick calculations. They'll save you a lot of time and effort, and there's reasons behind all of them. So what I'd like you to do is pause the video and read these, not just the result but the reason as well, and you might want to put a shortened version of the reason in. So pause the video, copy those down and consider the reasons for them. You might notice, especially if the last two, the last one in particular resonates, because it's a bit like the example we just saw at opening the video. I'd like you to be aware of an alternative notation which gets used for NCR. So NCR can be written not only like that but also like this here. So that is the alternative format of NCR. Please note, because you will see that. Let's do 2 simple problems here involving our NCR, our combinations. And 6 points lie on a circle. How many triangles can you make using these points as the vertices? So, you know, if you need to draw the circle, there's no harm in that. You certainly don't have to do it. But you know, 6 points on the circumference of a circle, got 4 there, 5 and 6. And how many triangles can you make using these as the vertices? So, you know, there's 1. How do we make a triangle with the points? Well, that's not a triangle. So what else can we do? Well, we can connect up these. That's a triangle. Oh, okay. So what about another go? How do we make a triangle with different points? What do I need to make a triangle? I need another point. No point going back to the first one. What if I do that? Whoop! That's a terrible triangle. Okay. All right. So I need to choose 3 different points out of the 6. So choosing 3 different points out of the 6 is an NCR problem. So that would be 6C3. And from there on it's pretty easy going, isn't it? We have 3 factorial, 3 factorial. We get 20. So the next one here, each of the 20 people at a party shakes hands. Now we're assuming two-handed handshakes. Okay. We're also assuming that people only use one hand for a handshake, only the right hand and all that conventional stuff, so that makes it a 20C2. And if you, just to cut a long story short, showing the normal working, you would get 190. Last problem. So we've got to travel only right and down, and how many paths are there from A to B? And one way of looking at this is there's 8 movements that's going to happen, okay? And it doesn't matter which way you go, there's going to be 8 movements to go from A to B. And one way of considering it, there must be 3 downs at some stage. So how many ways is there choosing out of 8 movements, 3 downs? And that's an 8C3. And I expect you to show full working, but basically for the keep the video short, that's 56. Is there another way of doing this one? Pause the video and consider. Well, can we also consider it as 8 movements that involve 5 rights, 5 R's? Let's have a look at that. So that would be 8 factorial over 5 factorial times 3 factorial. Now this one here, of course, was 8 factorial. I didn't show it before, but it was 3 factorial times 5, so of course it's the same, isn't it? 8C5 is the same as 8C3, and so just like at the start of the video, we're going full circle. Yep, it's 56. So da-da. So selections or combinations with